Welcome back. So in the last video I explained to you about some current trends and I finished talking to you by the theory of ionization energy. So a contrast occasion happens when you think about gaining electrons. Now one of the ways of gaining electrons is through electron affinity, and another way of describing the effect of electrons on an atom is the electronegativity. So those two concepts will be the basis of this video. So let me begin with the concept of electronegativity by giving a simple introduction about it. So electronegativity is the tendency of an atom to attract electrons toward itself in a molecule of a compound. Now for example, if you take an atom and a molecule like sodium chloride, so chlorine has some electronegativity, sodium also has some electronegativity, but since the electronegativity of sodium is so small, we assume that sodium to be an electropositive ion actually, and chlorine to be an electronegative because its electronegativity is high compared to sodium as sodiums. So electronegativity is actually a measure or a scale in which we measure the whether bonds are ionic, bonds are covalent, or bonds are polar covalent, non-polar covalent, and so it's not only used in bonding, it's also used in various other topics in chemistry. You may have already come across those, and I have explained those in one of my previous videos. So in this video I will talk about the effect of electronegativity on the periodic table. So the value of an electronegativity of an element explains the ability of an atom, of its atom, to compete for electrons with the other atom to which it is bonded. So what I mean by that is that the difference in these electronegativities will result in different kinds of variations. Now for example, you can take the same example of the bonding. Now if you take sodium chloride, it's an ionic bond, but if you take carbon tetrachloride, it's a covalent bond, right? So it's a non-polar covalent bond. So what actually happens is that now when the electronegativity, the difference of electronegativities between these two actually the two atoms in a bond. Now take a bond of two atoms, right? What I mean by two atoms is actually two elements, right? Not two atoms, two elements. For example, if you take a bond between sodium and chloride and carbon and chloride, so when I take carbon and chloride, I have to take four chlorides. So sodium chloride's electronegativity results, the difference of electronegativities of the sodium chloride atom results in an ionic bond. The difference in the electronegativities for carbon tetrachloride result in a covalent bond. So this electronegativity is important in bonding. So electronegativity also results in the variation of atomic characteristics in the periodic table. However, electronegativity is also related to the ionization energy. So ionization energy I finished talking in the last video. So electrons with low ionization energies we have experienced that have low electronegativity. So actually the ionization energy can be actually considered to be directly proportional to the electronegativity. It doesn't happen so. What I mean by that is when the ionization is low, you can remember that the electronegativity is, you can keep a reminder that when the ionization is low, the electronegativity is also low. This happens because the nuclei do not exert a strong attractive force on electrons when the ionization is low. So for example, if you can say that when I take our sodium, its first ionization is the lowest, so its electronegativity will also be the lowest. So that's actually true because we can see from the both from the actual data or actual data tables of electronegativities and the ionization energies, as well as from the bonds formed, as well as other physical characteristics, that sodium has both the minimum first ionization energy and the minimum electronegativity because it's in the first group of elements in the periodic table. Similarly, elements with high ionization energies have high electronegativities due to the strong pull of strong pull exerted on the electrons by the nucleus. So you can take a similar example to clarify that as well. In a group, the electronegativity decreases as atomic number increases. So when you say take a group, the alkaline group, right, alkaline metals. So you can say that when you go from lithium, sodium, potassium and so on, you can say that the electronegativity decreases. This happens as a result of the increased distance between the valence electron and the nucleus, right, greater atomic radius. Now when the atomic radius increases, its attraction towards the nucleus decreases, resulting in a decreased electronegativity. So as I mentioned, there are, due to this electronegativity, there are various types of electronegativities. So elements with low electronegativity, as I mentioned a little while ago, are called electropositive elements. So for example, sodium, and you can say take hydrogen as well. While elements with high electronegativity are called electronegative or electronegativity elements. For example, you can take chlorine, right? Another example, you can take fluorine. Fluorine has the highest electronegativity. So I explained about the concepts of electronegativity in another video, so I will not explain about the electronegativity further in this video. So due to these changes in electronegativity, as I explained a little while ago, different bonds can be formed. For example, the sodium chloride bond is an electrovalent bond or an ionic bond, and the HCl bond or the hydrochloric bond is a polar covalent molecule or polar covalent bond. So due to these electronegativity differences, we can form different bonds, and these bonds and the other chemical structures and the chemical properties result in different characteristics among the elements and the molecules that you can find in the periodic table. So the last concept of the characteristic that I'll be talking about is the electroaffinity. So electroaffinity is the complete contrast of the ionization energy. Now in the case of ionization energy, what you did was you removed electrons. Now in the case of electron affinity, you give an electron. So in the case of ionization energy, whether it is for the first ionization energy or the second ionization energy, the ionization energy produced an ion with +1 more charge. For example, if you give some energy to a say magnesium plus ion, it will form the magnesium 2 plus ion, the popular magnesium ion, right, Mg2 plus ion. So in the case of electron affinity, what actually happens is that the ionic charge decreases when you are given electrons. For example, you can take chlorine, excuse me, when you take chlorine and when you give some electron, it forms the chloride ion, which we call the anion. So cations or cations are formed in the case of ionization energy, and anions are formed in the case of electron affinity. Since we give an electron, what actually happens is the reverse reaction of the ionization energy. Now in this case, due to this reverse reaction, energy is given out. Now in the case of ionization energy, we gave energy, and in the case of electron affinity, the energy is given out to us. So the electron affinity, in conclusion, is the ability of an atom to hold an additional electron, right? It should have the ability, right, to hold an additional electron. If the atom has more tendency to accept an electron, then the energy release will be large, and consequently the electron affinity will be high. Electron affinities can be positive or negative. It is taken as positive when an electron is added to an atom, right? So you can say that if you compare the electron affinities of sodium and chloride, you can say that since the sodium retains that it doesn't want an additional electron, it wants to take out that electron, right? It should have the contrast effect. The sodium atom wants to give out that electron, not take an electron, and form this Na minus ion. So Na minus ion is unstable, so it will be very difficult to form. So the electron affinity is very small, right? But in the case of chlorine, it has a high tendency to accept an electron, so its electron affinity is very large. So electron affinity, as in the case of electronegativity, depends upon various factors. It is measured in electron volts per atom or kilojoules per mole. It depends upon the extent of nuclear charge. For example, you can compare the electron affinities of chlorine and another atom, say sulfur, right? You can say that when the nuclear charge changes, the electron affinity changes in a similar way. It affects on the size of the atom. When you go down a group, or when you go from the left to the right of a period, the electron affinity changes in a very periodical and a recurring pattern. and also it depends upon the electronic configuration. So that's the most important concept, because you can distinguish in the case of the periodic table as in the case as also in the case of the electron affinity, that when the electronic configuration increases, the electron affinity should increase, and the element with the highest electron affinity is fluorine. So you remember that. So you can see here in the case of this table as well, this graph, you can see that fluorine has the highest electronegativity, which is 4.0. so this is actually in the case of a Pauling scale, right? So we use a scale called Pauling scale to measure the electronegativities. So electron affinity also is a direct influence or a direct derivation of the electron negativity. So when you go down a group, you can see that the electronegativity decreases. When you go from the left to the right of a period, you can see that the electronegativity increases. So some important points of the electron affinity is that electron affinity increases from left to the right axis of period because of the increase in nuclear charge and decrease in atomic size. Now you know that when you go from the left to the right of a period, the atomic size, what happens is that it decreases and the nuclear charge increases. So due to this reason, electron affinity increases. So this causes the incoming electron to experience a greater pull of the nucleus, thus giving a higher electron affinity. Now for example, if you take the sodium atom and the chlorine atom, or even the potassium and the bromine, right? Potassium and the bromine, you can see that in comparison, that bromine will have a higher experience or a greater pull of the nucleus, giving a higher electron affinity and a higher electronegativity. In a similar way, the electron affinity decreases down the group, right? So when you go down the group, the atomic size increases, right? You know that when it goes down the group, the atomic radii increases. So when you consider that these atoms to be spherical in nature, the atomic volume increases, so the atomic size increases. However, the effective nuclear charge decreases. So actually what actually happens is the converse of the first point, that when you go, right, when the incoming electron do not experience the same attraction as in the case of the previous element of that group. For example, when you compare sodium and potassium, so sodium atom, an electron to the sodium atom will experience a greater pull than that of the potassium, right? So electron affinity of completely filled atoms is almost zero. An atom does not accept an electron in its outermost shell if it is already has a stable configuration, a duplet or octet, as in the case of inert gases. So in the case of helium and other gases, helium, neon, argon, krypton, xenon, like that, you can say that the electronegativity is zero because it is completely filled. And also in some atoms in which you get an ion, if it is completely filled, again the electronegativity will be almost zero and the electron affinity will not be defined for such an atom. So in summary, you can say, now as I have been explaining you about these concepts in the last two videos as well, so let's summarize these concepts into two presentation slides. So one along a period, along a group, and the other along a period. So in summary, along a group, the chemical and physical properties vary as follows. So you can say that when you go down the group, the electrode positivity increases, or when you go up the group, so the electronegativity increases. The reduction ability increases when you go down the group. The size of atoms increases, size of ions, and the density increases, right? So size of atoms increases because of the increase of size of the atoms and the ions. You can say that the mass per unit volume also increases, mass also increases, the size also, or the volume also increases, so the density should also increase. So these factors increase when you are going down the group. When you are going up the group, the melting points, the boiling point, the latent heat, and the dissolution heats, all these heats and the temperatures, related temperatures, increases because of the heavy pull, or the nuclear pull to the nucleus for the electrons as held by the electrons. Because there's a huge pull, you should give high energy and high temperature. So along a period, in a similar way, you can see that, as I mentioned a little while ago, the electronegativity increases. So due to the increase in the electronegativity, the non-metallic characteristics also increases. So you may have also seen that these elements, these non-metallic elements, form the acidic qualities, right? So for example, if you take chlorine, it forms HCl. In the case of sulfur, it forms H2S, right? So it forms the acids. But when you go from the right to the left, the electropositivity increases. So when you go from the left to the right, the electronegativity increases. When you go from the right to the left, the electropositivity increases. So you should know that the elements in the first group have the highest electropositivity, and the 17th group, not the 18th group, the 17th group have the highest electronegativity. So you know that fluorine has the highest electronegativity, and the elements in the first group has the highest electropositivity. So the electropositivity increases when you go from the right to the left of a period. Metallic characteristics increases because you know that sodium and magnesium are very hard metals. The hard metals. Sodium and magnesium are very pure metals. Then we don't classify chlorine and the others, chlorine, sulfur, to be metals. So the metallic characteristics should increase when you are going from the right to the left. The size of atoms also increases, so that's evident from the concepts of the shielding effect and the nuclear charge, effective nuclear charge, as I explained in the last video. And the basic qualities increases. So it's very hard to find MgH2 or NaH. You can always see NaOH or MgOH2, AlOH thrice, right? Sodium hydroxide, magnesium hydroxide, aluminium hydroxide. So these elements, these metallic elements, tend to gain OH minus ions or hydroxide ions, hydroxyl ions, and form bases. So the basic qualities increase when you are going from the right to the left, and the acidic qualities increase when you are going from the left to the right. So that is it about the variations and the summary of these trends along groups and along periods. So these two slides will present you with some other trends. So these about the variation of the latent heat of fusion across the periodic table, right? You can see that silicon has the highest latent heat, and elements here, oxygen and the other stuff, the fluorine, they have the latest latent heat of fusion. And this is about the density. So osmium has the highest density. So this is actually a hard variation, you can see, right? It doesn't have a periodic variation as in the case of the electron configuration. But that's it about the variations and the trends of the periodic table. So this this video will terminate the videos on periodic table. So in the first video I explained to you about the introduction of the periodic table and the characteristics and the categories of the periodic table, the groups, the periods, and the blocks. The second video of this period on the series of videos on periodic table explained you about the characteristics and the chemical and the electron, actually the periodic trends, the introduction to periodic trends. So there I explained about the electronic configuration, the atomic radii, and the ionization energy. So in this video I further explained to you about some other periodic trends, which are the electron negativity and the electron affinity, and I finally explained to you about a summary of these trends along groups and along periods. So thanks for watching all these videos on the periodic table, including this video, and I'll see you next time with a new concept on chemistry. So thanks for watching this video, and see you soon.